Students, good morning. In the last class, in the D block elements chapter, we are already discussed color properties exhibited by D block elements. Very important topic. How D block elements exhibit colors, or why only D block elements form colored compounds, but not S and P block elements. And we found some valuable reasons behind that. The one is d orbital splitting, and another one is dd transitions. Okay, and that's why students, in aqueous state, the metal ions which belongs to D block, if they contain at least one unpaired electron, they are capable to form colored compounds. It's clear, no doubt at all. And we are all standing on that one golden statement: D block elements form colored compounds if and only if they have at least one unpaired electron. That is the golden statement of what we have in my previous class. But students, still I am standing on the color properties of D block elements. Now, let me give an idea, some surprising things. Students, we know one thing, KMnO4 means potassium permanganate and potassium chromate, K2CrO4, and potassium dichromate, K2Cr2O7. In our laboratory, KMnO4 appears as in purple color. Keep in mind. Tick quiet. What about K2Cr4, sir? It appears in yellow color. What about potassium dichromate, sir? It appears in orange color. But students, while we coming to the oxidation state of central metal here, we are all capable to calculate oxidation states. Say this is X, potassium already +1 and oxygen -2. Dear students, 1 plus X minus 8 is equal to 0. Then absolutely X is equal to +7. Means manganese exists in +7 oxidation state. Sir, what is actually manganese, sir? Actually manganese is after argon 4s2 3d5, because atomic number is 25. Sir, manganese +7 means, sir? Manganese +7 means we found no electrons, means 2 electrons and 5 electrons, both are removed. So total 7 electrons removed. So manganese has which configuration now, sir? Manganese has only argon configuration. Keep in mind, only argon configuration. Means manganese possesses no unpaired electron. There is no unpaired electron. But still KMnO4 exists in purple color, sir. What is the reason behind that? While we coming to K2Cr4, say this is +1, say this is X, say this is a -2, and once again I think chromium oxidation state becomes +6. And here once again this is +1, this is X, this is -2, and this is 2 plus 2x minus 14 is equal to 0. Absolutely X becomes +6. So in both cases chromium exists in +6 oxidation state, dear students. We know already chromium, I think 4s1 3d5. What about chromium +6, sir? Chromium +6 means we are ready to remove these 6 electrons. Means 0 0. Then obviously chromium also achieve argon configuration. Keep in mind. Means chromium +6 also have no unpaired electron. Here manganese +7 has no unpaired electron, and chromium +6 has no unpaired electron, dear students. But still KMnO4 exist in purple color, and chromium compounds in +6 oxidation state exist in yellow color and orange color. So what is the reason behind that, sir? Dear students, and this is our challenging topic, and this is our challenging aspect while we discussing about the color properties of D block elements, dear students. But చాలా సందర్భాల్లో అడిగాడు మనల్ని వాడు చూడు ఎంత కన్ఫ్యూజ్ చేస్తాడు క్వశ్చన్ ని. dear students, KMnO4, just look at KMnO4 and K2Cr2O7, dear students, and K2Cr4, they exhibit, dear students, they exhibit color due to, and question is that we all look for an answer DD transition like that. But the thing is, dear students, they exhibit color due to only a charge transfer phenomena. Oh, what a topic this is! Charge transfer phenomena, but not, dear students, but not due to DD transitions. Reason assertion question ఒకసారి వాడు అడిగింది నీట్ ఎగ్జామ్. KMnO4 exists in purple color. Assertion. Reason is that is due to DD transition. So what's your answer, students? Assertion is right, but the reason is wrong because these compounds never show DD transitions. Why, sir? Because these compounds have no unpaired electron, man. Once there is no unpaired electron, how electron jump from lower level to higher level? So there is no chance for DD transitions. Is it clear? So that's why we found for a new phenomena which is responsible the color exhibited by these compounds, and that is nothing but charge transfer phenomena. Very, very important for students in objective point of view. Now let me coming to what is charge transfer phenomena, sir. A different charge transfer phenomena takes place, but now let me introduce LMCT. So LMCT charge transfer phenomena. L means what, sir? Dear students, L means ligand. M means what, sir? M means, dear students, metal. C means what, sir? C means charge. T means what, sir? T means transfer, dear students. So ligand to metal charge transfer phenomena which is going on here, and that is responsible why these compounds exhibit color even though they have no unpaired electron, dear students. And students, to well explain this one, I have considered KMnO4. KMnO4 means what, sir? KMnO4 means MnO4 minus. K plus MnO4 minus. Keep in mind. Sir, are you have any idea about its structure, sir? Why not, students? I have its structure. Just look at Mn double bond O and Mn double bond O and Mn double bond O, and this is O minus, dear students. Is it clear? Okay. O minus means what, sir? Dear students, just look at two electrons, two bond pair of electrons are already present on oxygen here, and with the addition of one more electron due to which charge anna negative charge, keep in mind. So that's what we call simply MnO4 minus structure. Very, very important one, dear students. Please look at that. Now, sir, suddenly what is going on here, students? Now let me explain. Just observe what is going on here. Before I am going to explain, I am just ask a small question. MOED diagram of oxygen molecule. I remember MOED diagram of oxygen molecule in chemical bonding chapter. Students, I remember these are 2p level. Okay. Now let me explain. Friends, I remember these diagrams in our chemical bonding chapter. Okay, so this is, I think, sigma 2px, and this is pi 2py, and this is pi 2pz, and this is pi star 2py, and this is pi star 2pz, and this is sigma star 2px. Dear students, లేదు కొన్ని బుక్స్ లో దీన్ని z అంటాడు, దీన్ని x and y అంటాడు, నో ప్రాబ్లం. సో ఆక్సిజన్ రాయాల్సి వస్తే 1 2 3, dear students, 4 1 2 3 4, and that's why these bonding molecular orbitals are completely filled, and these are these are anti-bonding molecular orbitals. Anti-bonding molecular orbitals contain 2 unpaired electrons, and that is the reason behind why O2 is a paramagnetic behavior. Keep in mind, students. And students, while we coming to this particular one, here these electrons are called a non-bonding electrons. Non-bonding means lone pair electrons, but 2 unpaired electrons are present in oxygen. But we are talking about O minus, means already one electron is paired up. So only one unpaired electron is there. O minus kabatti already one electron pair up ayindi. Inka only one unpaired electron maatrame undi. So it contain, dear students, one unpaired electron in what sort? In anti-bonding, dear students, molecular orbital. Anti-bonding molecular orbital. Keep in mind, that's what I am saying, anti-bonding molecular orbital. What about manganese oxidation state here, sir? Manganese oxidation state absolutely plus 7, no doubt here, because we already calculate manganese oxidation state is plus 7. Sir, what is going on here? Students, you just look at that. Ligand to metal charge transfer. What is ligand, sir? Dear students, electron pair donors are always ligands. Here oxygen donate lone pair of electrons to manganese plus 7. Keep in mind, and that's why oxygen atoms we simply consider as ligands. So if the ligands lo unnatuvanti unpaired electron, dear students, and this unpaired electron, keep in mind, just transfer to Mn plus 7 orbitals. So unpaired electron edaithe undo O minus lo unnatuvanti unpaired electron. So unpaired electron anti-bonding molecular orbitals nunchi, dear students, ఆ manganese plus 7 లో ఉన్నటువంటి bonding molecular orbitals లోకి charge ని ట్రాన్స్ఫర్ చేసే ఫినామినాని చూపిస్తుంది. దాని అందుకనే ఎక్కడ కూడా మనం dt ట్రాన్సిషన్ అంటున్నాం, ఎందుకంటే లైగెండ్స్ లో ఉన్నది ఇక్కడ మనకి d ఆర్బిటాల్ కాదు. సో we name their quality as a dt transition. So these are simply anti-bonding molecular orbitals which are present in the ligand. So if one unpaired electron is transferred from O minus to manganese plus 7, then what happens, sir? Dear students, manganese plus 7 after gaining one electron turns to manganese plus 6, dear students. Okay, charge transfer. Just look at the word, what is going on? Charge transfer. Here charge is plus 7, here charge is plus 6. Okay, so once manganese achieve plus 6 oxidation state, then it has one unpaired electron, and that unpaired electron absorbs some energy radiations and immediately emitted out some energy radiations, and that emitted radiations belongs to which color in Wigner zone? That compound exhibit that color. In case of KMnO4, the emitted radiations are present in purple color zone, and that's why KMnO4 exhibit purple color, dear students. So no DD transition, keep in mind, no DD transition, only charge transfer. So one of the electron from anti-bonding molecular orbital of ligand jump into bonding molecular orbital of metal ion. Only charge is transferred, no DD transitions, keep in mind. So that's why Mn plus 7 oxidation state becomes Mn plus 6, charge transfer. And after Mn plus 6 we achieved, we have one unpaired electron which is further responsible to exhibit color. So the color of purple color of KMnO4 is mainly due to a charge transfer phenomena, but not at all DD transitions, dear students. Most important one, in examination point of view, keep in mind. Students, after charge transfer phenomena, now let me come into color due to distortion of electron cloud. Different objective topics, all these are particularly for mains and NEET. Okay, now color due to distortion of electron cloud means what, sir? Let me explain. Students, I remember last year organic chemistry, qualitative and quantitative estimation of organic compounds. We have, dear students, the estimation of chlorine, bromine, iodine. I remember that thing. Estimation of chlorine, estimation of bromine, and estimation of iodine by Carius method. Okay, so in that method, we found chlorine as AgCl, we found bromine as AgBr, we found iodine as AgI. Okay na, మీరు ఇప్పుడు సాల్ట్ అనాలిసిస్ రాస్తున్నారు కదా నన్న మన రికార్డ్స్ లో, ఆ సాల్ట్ అనాలిసిస్ లో రాసినప్పుడు క్లోరైడ్ కన్ఫర్మేషన్, బ్రోమైడ్ కన్ఫర్మేషన్, అయోడిన్ కన్ఫర్మేషన్ ఒకసారి చెక్ చేయండి. AgCl precipitate ఫామ్ అవుతుంది. ఏ కలర్ precipitate సార్? వైట్ కలర్ precipitate, డియర్ స్టూడెంట్స్. AgBr precipitate ఫామ్ అవుతుంది. ఏ కలర్ precipitate సార్? పేల్ yellow కలర్ precipitate. సిల్వర్ iodide ఫామ్ అయింది. ఏ కలర్ precipitate సార్? థిక్ yellow కలర్ precipitate. Again confuse students, they exhibit color. But when we coming to silver, silver belongs to which group, sir? Dear students, silver belongs to 6th p group. Means which family? Which family? Copper family. Okay, configuration of silver, configuration of copper, 4s1 3d10, absolutely. Okay, while you coming to silver, I think this is 5s1 4d10. Am I right or wrong? Because this belongs to 3d series, whereas this belongs to 4d series, and that's the thing going on here. So in these compounds, absolutely silver exhibit +1 oxidation state, +1 oxidation state. While we're talking about +1 of silver, it becomes 5s0. What about 4d10s are? Dear students, 4d10 means all are paired electrons. No unpaired electron, underline this word, no unpaired electron, no DD transition. But still these compounds exhibit color. Challenging topic. Why so? And this is mainly due to a distortion of electron cloud. And we also call it as a process of polarization ability, dear students, of metals or metal ions. Polarization ability. Last year మన chemical bonding chapter లో నేర్చుకున్నాం, గుర్తుందా? పోలరైజేషన్ ఎబిలిటీ. పిల్లలు ఒక చిన్న ఎగ్జాంపుల్ చెప్తాను మీకు నేను. స్టూడెంట్స్, Li ప్లస్ రా, ఇది Na ప్లస్ రా నాన్న, K ప్లస్ రా, ఆర్ B ప్లస్ రా, ఇది ఏమో Cl మైనస్ నాన్న. అది గాట్ ఇట్ రా. Li ప్లస్ అంటే 2s2, Na ప్లస్ అంటే Li plus అంటే 1s2. 1s2. Na ప్లస్ అంటే 1s2 2s2 2 pieces. దీనికి 3 షెల్స్ ఉంటాయి. రుబిడియంకి ఎన్నిసార్ 4 షెల్స్ ఉంటాయి. సో ఇది నెగటివ్ చార్జ్ క్లౌడ్ అరౌండ్ క్లోరిన్. సో ఇప్పుడు ఈ క్లోరిన్ చుట్టూ ఉన్నటువంటి ఆ ఎలక్ట్రాన్ క్లౌడ్ ని, యానియాన్ ఎలక్ట్రాన్ క్లౌడ్ ని క్యాటయాన్ తన వైపు అట్రాక్ట్ చేసే ఎబిలిటీనే పోలరైజింగ్ ఎబిలిటీ. సో ఎవరికైతే పోలరైజింగ్ ఎబిలిటీ ఎక్కువగా ఉంటుందో, more polarization, and that results which bond, dear students, covalent bond. Remember this one? And that's why among LiCl, NaCl, KCl or BCl, which is more covalent, or LiCl is more covalent because lithium is small in size, nucleus attraction force very very high, so it strongly attract electron cloud towards itself, so more polarizing ability, dear students. So once atomic radius increases, nucleus attraction force decreases, polarizing ability is also decreases, dear students. And that's why for cations polarization ability is more, dear students. For which type of cations are absolutely those cations which are small in size. Okay, so that's why, dear students, small size cations which possess a very very high nuclear charge, and those high nuclear charge cations, they just polarize the electron cloud around anion, dear students. మరి యానియాన్స్ లో ఎలా ఉంటుంది సార్ ఈ ఎబిలిటీ? Li ప్లస్ తీసుకుందాం. ఇప్పుడు యానియాన్స్ చూద్దాం. F మైనస్, Cl మైనస్, Br మైనస్, dear students, ఇక్కడ ఒకసారి మీకు ఎక్స్ప్లెయిన్ చేసి చూపిస్తాను నేను. ఇది Li ప్లస్ అనుకుందాం నాన్న. Say this is F minus, say this is Cl minus, say this is Br minus, say this is I minus. F minus means what, sir? 2 shells. Cl minus means what, sir? 3 shells. Bromine, sir? 4 shells. Iodine, sir? 5 shells. Okay, now lithium plus is ready to polarize. It is ready to withdraw electron cloud. So ఇప్పుడు 4 యానియాన్స్ లో ఏ యానియాన్ ఫాస్ట్ గా ఎలక్ట్రాన్ క్లౌడ్ ని Li ప్లస్ ఇస్తుంది సార్? వెరీ ఇంట్రెస్టింగ్ వన్. ఓకేనా? సో ఏ యానియాన్ లో అయితే ఎలక్ట్రాన్ క్లౌడ్ న్యూక్లియస్ కి ఫార్ అపార్ట్ గా ఉందో, డియర్ స్టూడెంట్స్, అక్కడ నుంచి డిస్టార్షన్ ఆఫ్ ఎలక్ట్రాన్ క్లౌడ్ ఈజీగా జరుగుతుంది, పోలరైజేషన్ ఈజీగా జరుగుతుంది. అంటే F మైనస్ స్మాల్ సైజ్ కాబట్టి ఎలక్ట్రాన్ క్లౌడ్ న్యూక్లియస్ కి దగ్గరగా ఉంటుంది. రేడియస్ పెరిగే కొద్దీ, అటామిక్ రేడియస్ పెరిగే కొద్దీ, డియర్ స్టూడెంట్స్, ఎలక్ట్రాన్ క్లౌడ్ ఫార్ అపార్ట్ ఫ్రమ్ న్యూక్లియస్ కాబట్టి ఈజీగా పోలరైజేషన్ అయ్యే ఎబిలిటీ ఉంటుంది. సో ఇప్పుడు ఇక్కడ ఉన్న వాటిలో మోర్ పోలరైజేషన్ ఎవరికి సార్? సందేహమే లేదురా నాన్న, లిథియం అయోడైడ్. అందువల్లే ఇది కోవలెంట్ నేచర్. Lithium fluoride less polarization, ionic nature. Are you got it? So small size cations or high nuclear charge cations have high, dear students, polarization capacity. ఎక్కువ polarization capacity వాడుతుంది. Okay, now but what about anions, sir? Dear students, anions with large size are easily polarized. Large size ఉన్నవి ఈజీగా పోలరైజ్ అవుతాయి. సో ఎక్కడైతే, డియర్ స్టూడెంట్స్, మనకి మోర్ పోలరైజేషన్ జరుగుతుందో, జస్ట్ లుక్ ఎట్ దట్ స్టూడెంట్స్, వేర్ వి ఎక్స్పెక్టెడ్ మోర్ polarization. Polarization means what, sir? Polarization means a distortion of electron cloud. Distortion of electron cloud means migration of electron cloud from anion to cation, and that distortion of electron cloud, which is responsible for the excitation of electrons. Dear students, excitation of electrons. During distortion, dear students, electron jump from lower level to higher level. It is not at all stable there. Again, it comes back to ground states. Why? It moves from anion to cation. Dear students. Okay, and that distortion of electrons, that polarization responsible for excitation of electrons, and which is further responsible for the color exhibited by such compounds. Students, what we coming to one thing here? This is Cl, chloride. This is Br, bromide. This is iodide, iodide. Where we expected more polarization, absolutely large size of anions are, and that's why in case of iodines. More polarization, more color it is exhibited. Thick yellow color. Bromine has less polarizable ability compared to iodines, and that's why pale yellow color. Chlorine is very small size, almost very less polarizing ability, and that's why it exhibits in white color, dear students. And that's why, students, this is another phenomenon. The color exhibited by few compounds, simply polarizing ability of ions or the distortion of electron cloud. Why only D block elements show this polarizing ability by exhibiting colors are because D block elements are having high nuclear charge, dear students, but not S and P block elements. Now let us consider this is AgCl exhibit color. What about NaCl, sir? No. This AgBr exhibit pale yellow color. What about NaBr, sir? No. This ACA exhibit yellow color. What about sodium iodide, sir? No, no color. Because sodium has no such a high nuclear charge to exhibit that too much polarization, which is further responsible for the excitation of electrons and which impart color. Only D block metal ions show such a high nuclear charge, and that's why they have high polarizing ability to exhibit color, dear students. So these are very important, students, in objective point of view. This is complete class towards color properties. Please observe, students. మీరు ఒకసారి ఆ వీడియో చూసిన తర్వాత వెంటనే దాన్ని నోట్స్ రాసుకునే ప్రయత్నం చేయండి. ఈ నోట్స్ మీ దగ్గర ఉంటేనన్నా ఆ తర్వాత ఈ చాప్టర్ మీరు ఎప్పుడూ ప్రిపేర్ అవుదాం అనుకున్నా కూడా అవ్వచ్చు. ఓకేనా? థ్యాంక్ యూ, స్టూడెంట్స్. థ్యాంక్ యూ, everyone. In our next class we are discussing about another topic. Okay, catalytic properties of D block elements. Thank you, Nana. Bye.